So now we have to model in an electrical circuit. We have seen modeling of mechanical system. In modeling of mechanical system, two types are there. One is modeling of mechanical translation system, where the three components is mass M, dashpot P, and spring C. And in mechanical rotational system, it was Func straight road, that is momentum inertia. That is J for momentum inertia, dashpot P, and spring. Based on that, we have found the differential equation, and based on that, we have found the transfer function. We know the definition for transfer function. What it is? Laplace transform of output to the Laplace transform of input with zero initial connection. That should be mentioned. Okay. So now for modeling of an electrical circuit, the circuit will be like this. See, if there is an E of t, everything happens with respect to time t. So if E of t is the input to an electrical circuit that is having RLC series. Okay. So let inductance, and there is a resistance series connected to it, and there is a capacitance over here if it is connected like this. So this is a series RLC circuit. Name it as R and C. Okay. To find the transfer function for this electrical circuit, what we have to do is first the three elements and its symbol. Okay. And next is time domain, how it will be represented in terms of time. And what if we take Laplace transform, what is the formation of it? So, in order to write the differential equation, what we have to know? We have to know with respect, there is S domain, with respect to time we want to know. And next is Laplace transform will be in S domain, right? So, these condition things we want to know to frame the differential equation first. Okay, after finding the differential equation, what we have to find out? Transfer function. Okay, here, you know that first, we are getting an input. That is E of t is our input in an electrical circuit. Okay, our transfer function is a system that will be mentioned as G naught of S. Okay, this is the transfer function. Okay, and here it will be an output. Now listen, where we are getting output? The output will be across the capacitance C. So it will be the V naught. So I have to find out the transfer function means what I have to find out transfer function, that is G naught of S is equal to output, where output comes C. So the G naught of S divided by the input, what it is? E of t. If you take Laplace transform of the input, what it will be? E of S. This is what I have to find out from the electrical system. Okay, first elements you have to know. That is resistor, inductor, capacitor. You know the symbol for each. That is for resistor, it will be drawn like this. The current of the resistor with respect to time is I of t, and the voltage across the resistance is V of t. And for inductance, it is mentioned as the symbol L, and the current for the inductor is I of t, and the voltage across is V of t. And likewise for capacitance, the current flow it is I of t, and voltage across is V of t. And how we can write it in time domain. Okay, you know that the basic law of capacitor you have studied that I P is equal to I into R. So the current for the resistance R is multiplied with I. That's it. So what is the current capacity with respect to time? I of t. So I of t into resistance R. And for inductance, how it will be written as d I by dt. Okay, that is inductance L into differential with respect to time. So d I of t divided by dt. And for capacitance, how it will be written as 1 by C. In capacitance, capacitance shows what? And inductance. What is the difference between capacitance and inductance? Inductance will shows current. Okay. Both are storage devices. It varies based on the storage element, storage source. Okay. So inductance shows the current. So we will say with respect to t, I of t is changing. So that is how L V R by dt. So capacitance we have been studying C into dV by dt. Differential of voltage energy is stored in the capacitance. If we have to write it in terms of current, means it is integral. Okay, actually capacitance stores voltage. The formula for capacitance is C into dV by dt. Okay, for in terms of current we have to write, we have to take the reciprocal of the differential, that is integral. Okay, so we will write as 1 by C integral of the current I of t into dt. So if you take Laplace transform for this, how it will be for resistance R is constant. So R into I of t should be written as I of s. So L here constant. So if it is a single differential means how we want to have it right now? S into. So L into S into I of t we have taken Laplace transform as I of s. And for capacitance it is written as 1 by C. So 1 by C for integral Laplace transform is 1 by S. For differential what it is? L d I by dt, or else in the previous mechanical system we have studied V into dx by dt. Okay. What about the differential of first order is written as yes. Right? So the differential of the second order is written as it is dx square x by dt square. Okay. Differential of second order is written as s square in s domain. Okay. Likewise, the integral s domain is written as 1 by s. So already that is 1 by c into 1 by s is taken like this 1 by sc. What is the current over I of s? Okay. So now based on this one you are now going to find out the differential equation format for this electrical electron. Okay. Now this is the current which is flowing with respect to, that is the current I of t. So you know that KVL. How will you writing it? What's the current input? That is apply KVL. Okay. If you apply it, E of t is equal to what? The sum of the current of voltage that is close to it. Okay. So here there is a voltage across it that is named as V of t, and the voltage across the resistance is also V of t, and here is also what happened? V of t. So what happened? You have mentioned it already. Okay. So it will vary based on the elements. Okay. It will vary based on the elements. So right now, for L, how we have to write out L into di by dt. Okay. And for resistance, how we write out R into I of t. And for capacitance, how we have to write out 1 by C into integral of I of t dt. This is a differential equation. Okay. So one get that one. Okay. Now take Laplace transform. Now take Laplace transform of the equation for equation 1. So how it will become? If you take Laplace transform of here, it will become capital E of S. So that is equal to your take Laplace transform it as L into S into I of S, and here it is R into I of S, and here it is 1 by SC, right? SC into I of S. So here, who is found over here? I of S, and the third term there is a I of S. So what happens now? E of S is equal to what? I of S if we take common outside, LS plus R plus 1 by SC. Okay, and now next. Next, we can able to cross multiply this towards it. Okay, here is a plus. So now we can cross multiply this in order to get a common denominator. Okay, so what happens? E of s is equal to what? I of s into LSC. S into S will become S square. I am writing this C over here. It is LC S square. Okay, next. Plus RSC. Can I write this RCS? Okay, RCS plus 1 with the whole divided by S into C. This is the term E of S is equal to with respect to current I of S. Okay, now let me do. Okay, we have to substitute this in some better system. Okay, what I have said, transfer function is G naught of S is equal to what? The voltage, output voltage is across to capacitance. That is V naught of S divided by E of S. So for V naught of S is across the capacitance. So what does the voltage of the capacitor we want to know, right? So the voltage of the capacitor is the output voltage V naught. So the voltage of the capacitor, how we can write it now?
1 by C
Voltage of the capacitor V of S is equal to 1 by C integral of I of t dt. So if we take Laplace transform for this, so Laplace transform, how it will become? V naught of S is equal to 1 by Cs I of S. So consider this as third. Now we know V naught of S as well as E of S. Can you substitute the transfer function formula? That is transfer function G naught of S is equal to what? V naught of S divided by
E of S.
E input, output divided by input is what? We have to mention zero initial condition. It's zero initial condition. And now, what is your V naught of S then? V naught of S is equal to
1 by Cs
1 by Cs into
I of S.
I of S divided by, so here
I of S
I of S
LCS
into LC square
plus
plus
RCS
RCS plus 1 over divided by
SC CS.
SC or CS. Okay. So now, shall I answer this? I of S. This 1 by C will come here over, right? So I can add it. CS and this C, right? Both are same. So we can cancel it. So what is the term remaining? That is the transfer function G naught is equal to
1 by
this term will become 1 divided by numerator LC square plus RCS plus 1. That's it. This is how we will be finding the transfer function of an electrochemical system. Okay. Whatever may be the elements, if it is not like this, one more element is getting added, means we have to add it. It will be named as L1. Okay, if I am drawing one more element, like for example, because we usually copy this, then I will do it. So, if the questions will be like this. Okay, so consider an electrical circuit. If it is not an oral circuit. Okay, maybe like this. Here is the input. Here, inductance should be not as L1. Then make that here. Resistor you can mark as R. Okay, and suppose if there is a inductance between and if there is a capacitor as well as the output, there is a inductors or a capacitor. If the circuit is like this. Okay, so here it is marked as L2, it may be C and it is L2. What do you have to calculate? Output voltage will be R or C, L3. So, how will we calculate the question of writing? Applying KVL now, E of T is equal to L1 T, KVL is what? I of T. Okay, so we will write it as L1 T I of T by T. For R I of T. And for L2 T I of T by T. For C it is 1 by C integral of I of T. Everything you have to add it plus. After that, what is that? L3 T I of T. Okay. So after framing the equation, what you have to find out from this? E of S. After taking Laplace transform, E of S you have to find. So after finding E of S, you have to find out the transfer function across to L3 of S. So V naught of S you have to find. So V naught of S across L3. So you will be finding L3 for L3. T I of T by T. It will be as L3 S into I of S. So from solving this equation, for applying KVL, after taking Laplace transform, you have found out E of S, right? So the transfer function you have to find as transfer function is equal to what?
V naught of S.
V naught of S, okay. V naught of
S
by C of S, which you have found out. Substitute both the things, cancel and suppose everything is going to cancel. After that, the final output is your transfer function. Okay. However, maybe the circuit, the same procedure if you follow, you will be getting the transfer function. And now, put on the next heading. That is